Number 2, determine whether the light figure maps onto the darker figure by the reflection in line M. So basically you can just trace the figure and fold it over this line and it should fall onto this figure exactly. And this one is a yes. It does have reflectional symmetry here. Okay, number 3, we want to graph each figure and its image, so we've got 2 jobs here after the specified rotation about the origin. So that means that all of these are going counterclockwise, and we're just looking at the rules that we learned in our notes. STU has vertices of S, which is 2, -1. T is 5, +1. And U is 3, 3. And we want to rotate it 90 degrees. So the rule for rotation of 90 degrees is we take our XY and we flip the Y value and make it negative, and then we put our X value in the original Y position. So 2 is X and Y is -1, so that's going to become -Y first, which is a +1, then X, so 2. T will be, here's our X, here's our Y. We want to take Y and make it negative first, so -1, and then leave our X alone. And with this one, U is 3, X is 3, Y is 3. So we're going to make our Y negative, and then our X stays the same. So plotting the points, we have -2, -1, that's our original S. T is 5, 1, 1, 2, 3, 4, 5, up 1. Oh wait, sorry. S is going to be 2, -1, 2, -1. And then U is 3, 3, so 1, 2, 3, 1, 2, 3. And then plotting my S prime, T prime, U prime. S prime is 1, +2. T prime is -1, 5. So -1, 1, 2, 3, 4, 5. And U prime is -3, 3. So 1, 2, 3, 1, 2, 3. And then connect our dots. Pretty close. As a rotation of 90 degrees. Okay, so 7 through 10 is just asking for the coordinates. So we don't have to rotate it on the coordinate plane. We just want to know what the coordinates are after the specified rotation. So once again, when it says about the origin, it means we're going counterclockwise. We're just following the rules on our rule sheet. So here we've got 90 degrees again. So we take our XY coordinates and we flip the Y position. So it's -Y first and then X last. So I'm just going to label all of my coordinates X and Y. So J prime, I take my Y value and make it negative. So 6 becomes a -6. And then I leave the X value as it is. K prime, I take my Y value, make it negative, so -2, and X stays the same. And L prime, take my Y value, make it negative, so -5, and X stays the same, 7. Okay, so number 13, it asks us to state whether the figure has rotational symmetry, and then if so, copy the figure, locate the center of symmetry. That means we can just turn it around, and then state the order and magnitude of symmetry. Furthermore, we want to state whether or not the figure has point symmetry. So remember that point symmetry is when it has rotational symmetry of 180 degrees. So for number 13, I'm just going to roughly trace the image and then see how many times I can turn it. Let's try that again. We got 1 turn, 2 turn, 3 turn, 4 turn, 5 turn, and 6 turns. So our order is 6, and our magnitude is we take 360 divided by our order, which is 6, and that'll give us a total of 60 degrees for our magnitude. It does not have point symmetry. Point symmetry is when it only has 180 degrees to turn it, where it rotates back on itself. So number 15, if you look at number 15, I can turn this thing around 180 degrees and it falls back on itself. So that one does have point symmetry. And finally, number 19, we want to find the image of each polygon with the given vertices after dilation with the given scale factor. So basically the scale factor, well, here the scale factor is 2, so that means that our image should be getting bigger because it's a scale factor greater than 1. And all we have to do here is take our scale factor and multiply it to each of these coordinates, because each of these coordinates is going to increase by 2. So j prime will become 2 times 2, which is 4, 4 times 2, which is 8. K prime will become 4 times 2, which is 8, 4 times 2, which is 8. And then P prime will become 3 times 2, which is 6, 2 times 2, which is 4. And I'd like for you to graph the original and then graph the image, and so you can get an idea of what it looks like. Clearly I didn't give enough room on this graph, so if you extended the graph and looked at the points, they would fall outside of the graph, and clearly this is an enlargement.